Welcome students to Lesson 7 of the Natural Hazards topic. In this lesson we will be exploring how people around the world have been able to reduce the risks from tectonic hazards, so earthquakes and volcanoes. And you will then see why it is that people choose to live near these hazards despite the risks that they face. Please write the date, title and learning objective and have a pen and paper ready to learn. Time to review prior learning. Write 1 to 10, answer the questions from memory, and then mark your answers. Game time. 1. Distribution. 2. Shield volcano. 3. Hazard risk. 4. It was 7.9 on the Richter scale. 5. An immediate response. 6. It was about 55,000. 7. The Richter scale. 8. About 60 countries. 9. Sanitation. That's sewers and clean water supplies. 10. Subduction is the process. Give yourselves a mark out of 10. If you got 8 or more, awesome work. I salute you. You've really understood these ideas. Any questions that you got wrong or missed out, come back to them in a week's time and test yourselves on them repeatedly until you've memorized them. To introduce the idea of reducing hazard risk, I'm going to show you 2 photos and I'd like you to answer the questions. Then we'll discuss them. So question 1. What factors affect the amount of damage that an earthquake causes, such as here? Well, you should have said development, and by that I mean the amount of wealth that countries have is an important factor, since it determines the quality of the infrastructure, the buildings, and the resistance of the buildings to shaking from earthquakes. That's the key factor. You may also have said the foundations of the buildings, the type of rock that buildings sit on. If a building is on soil shakes much more in an earthquake, and so the building will collapse more easily. If buildings are constructed on solid rock, then the shaking is less, and so the buildings are less likely to be damaged. You may also have said whether there's a tsunami or not, or whether the buildings are near the coast or not, affects the amount of damage. You may have said finally that if there's a fire, that will affect the amount of damage. Whether there's a fire or not will affect the amount of damage. 2. What could people do to reduce damage after earthquakes? You should have said that people can construct stronger buildings, for example using the Build Back Better philosophy, which means pay more for buildings so that they survive natural disasters. You may have said that people have safety mechanisms such as automatic shut-off on gas supplies, such as in Chile. 3. How did people know the volcano in this photo would erupt, and why did most people survive? Well, if you recall, in the previous lesson I told you that there was an American military base in the Philippines which used seismometers and other technologies to monitor the volcano, which allowed them to predict the eruption. And most people survived because they then evacuated many people from the islands. In this lesson we're going to explore these ideas further, especially of questions 2 and 3. And so you will see that there are many sophisticated and some less sophisticated ways that people around the world have used to reduce the impacts of earthquakes and volcanoes. Let's go. So the first way that you can reduce the impact of a natural hazard and the risk of being affected by it is to predict it. I take you to an island called Sicily, which is owned by Italy, and it's in South Europe in the Mediterranean Sea. And in the middle of Sicily live people like this. These are farmers who work on vineyards growing grapes for wine, and they live there despite Mount Etna, Europe's most active volcano, being present. This is the city of Palermo, and Mount Etna erupts vigorously, often on a yearly basis, occasionally threatening the lives of the people living on the island of Sicily. So what technologies have people used to be able to predict the eruptions of Mount Etna? Well, it all starts with this device. This is called a tilt meter. A tilt meter has a special balancing material within it that can sense even the tiniest changes in the angle of the ground, and these are placed all around the volcano. And through measuring the angle of the ground, a tilt meter can work out whether lava and pressure is building up beneath the volcano. If pressure and lava are building up, then that will bloat the volcano on its sides and it will change the angle of the slope. And this allows scientists to predict whether a volcanic eruption is about to happen. So tilt meters are a cheap and very effective way of predicting eruptions. Not only that, another important sign that volcanoes are about to erupt is that they emit gases. Gases are pushed out under high pressure through secondary vents called fumaroles in the sides of the volcano and through the tops. Here, a scientist is reading for a gas called sulfur dioxide, which has a stinking smell similar to rotten eggs and leaves yellow deposits behind. Higher quantities and concentrations of these gases being released suggest higher pressure underground and a greater chance that an eruption will happen soon. And so scientists are able to monitor these gases and the levels in which they're released to predict the likeliness of an eruption. It's not only that. When magma rises through a volcano such as Mount Etna, it cracks and shakes the rock around it. This causes minor earthquakes, tremors, that are picked up by devices called seismometers that have been laid around the volcano. And as the volcano shakes, the pen here moves up and down, giving readings of the size and frequency of these tremors. Frequency means how often they happen. When a volcano such as Mount Etna is about to erupt, the size of the earthquakes increases and the frequency increases as well, so they happen more often. And that tells scientists that an eruption is imminent and that people should evacuate. But that's not all. A modern and very advanced technology that is used to monitor volcanoes like Mount Etna are satellites. This satellite is in space, some 20,000 kilometers away from Earth, but it's able to monitor the temperature of Mount Etna on its top, called the main cone. When magma and gas rise up through the main vent of a volcano, they increase the temperature around the surface of the volcano, and this can be picked up by satellites, so that brighter spots here appearing over time tell scientists whether Mount Etna is going to erupt. And so through all these technologies, scientists in Sicily and Italy are able to predict eruptions with great accuracy, and this means that the people feel safe there and can be evacuated very easily and in time before an eruption occurs. Consequently, Mount Etna almost never kills people despite being a powerful, active composite volcano. So the first step to reducing hazard risk is predicting it. But what if you can't? What if you live in an earthquake zone? Then you have to protect yourself against hazards. Despite all the technologies and all the research that we have done into earthquakes, even the best devices for monitoring earthquakes can only predict them up to 30 seconds before the earthquake's about to happen, as in Japan. But that's not enough time to allow people to survive if a large earthquake hits a city, where thousands of people will be in schools and hospitals and office buildings. So you need to ensure that buildings are strong enough to resist them, and there are some advanced technologies that allow people to do that. Every morning, millions of people wake up in the city of San Francisco, on the west coast of the USA. And a great number of them go to this building here. It's called the Transamerica Pyramid. And it is an early example of very effective earthquake protection design. This building has been designed to resist even the largest earthquakes. It has survived a number of great earthquakes in San Francisco without any damage. Let me show you how. First of all, it has something called cross bracing, which you can see at its base here. The frame and the structure of the building is designed in X shapes like this. This X shape has been shown to sway less left and right than straight up designs like this here. And because it sways less, this means that the materials that are used to construct the building, such as glass and metal and concrete, are much less likely to break. This building, the Transamerica Pyramid, shakes much less than do other skyscrapers built in a traditional way, such as this. And consequently, it is less damaged. Additionally, when you're in the building, you feel the shaking of an earthquake far less than in other buildings made of, for example, brick. So cross-bracing is an effective architectural design feature that protects buildings from earthquakes. It's used around the world, not just in San Francisco in America. Another important feature of the Transamerica Pyramid is that its foundation isn't actually on the ground at all. It all starts with a giant hole in which enormous amounts of concrete are filled, but the building isn't built directly on the concrete, it's built on top of these. These are giant rubber pillars called base isolation. So the building here is actually separate from the ground here. And these rubber pillars act much like suspension on a bicycle. They absorb the shock waves from the earthquake, the seismic waves, and so the building does not feel the shaking from the earthquake. Much like you feel the shaking less in a car when it hits a pothole because of the suspension in the car. Consequently, with reduced shaking affecting the building, less glass and concrete is damaged, and so the building survives strong earthquakes. This base isolation is used in modern skyscrapers all around the world, especially those that are in earthquake zones on plate boundaries. It's an expensive technology, however, that is definitely not used in low-income countries, LICs, as much. Although, in Chile, the Grand Tower in the capital city Santiago uses this technology to support it, to resist earthquakes. Additionally, automatic safety features are very important to protect against earthquakes. Since you can't predict them, and since people often panic during an earthquake, it matters that a building can react instantly. In this situation, these buildings in San Francisco are designed with automatic gas shut-off features, this red device here, which means that the gas supply coming into the house is automatically cut off. It doesn't come in during an earthquake. And so if the gas supply is broken in the kitchen of the home, there's no gas that can spark and set a light and burn the house down. Additionally, here on these very same buildings, automatic metal shutters drop down immediately when they sense shaking from an earthquake, and so the glass does not blow up and injure people in the streets or in the home. And both of these features happen and react immediately to earthquakes, preventing injury to people. And finally, the most advanced and rarest used technology, but one that's very effective at protecting buildings against earthquakes, is called a tuned mass dampener. And this is most famously used in an enormous 500-meter tall skyscraper in Taiwan off the coast of China. In Taiwan's capital city is a building called the Taipei 101, and at the top of this building is a giant 100-ton metal ball that is suspended by cables, steel cables. And here's what happens. When the earthquakes shake the building, the Taipei 101, this device moves in the opposite direction to the shaking, balancing out the shaking and preventing the building from swaying. Consequently, with no swaying, the metal, the concrete and the glass don't bend, and so the building remains undamaged, even in the largest earthquakes. This is a very expensive technology only reserved for HICs, but it is also very effective. As well as protection against earthquakes and volcanoes, and prediction of volcanoes, people need to plan against these events. Should an earthquake strike, people need to know what to do, and there are three main ways in which governments prepare people for these events. The first is establishing and making well-known evacuation routes out of cities. If everyone in a city took one motorway out after an earthquake, then that road would become completely packed, people would not be able to escape in time and there'd be many more deaths. So, what is done in American cities, such as Los Angeles, is that there are designated evacuation routes given for people who live in different parts of the city. And consequently, roads never get too crowded, although they are clearly here, where the cars are being loaded up. So people are well aware of their evacuation route long before any large earthquake can happen. And news reports and education days constantly remind people of their own route out of the city. Evacuations are key before large hazardous events. But another important government strategy for planning for natural hazards is this. Scientists, through all their technologies such as seismometers and tilt meters and other ways of predicting earthquakes, create hazard maps like this. This is an earthquake hazard map for South America, and the different colours show the likelihood of a very powerful earthquake happening within the next 50 years. Red showing the greatest likelihood, and light green, and even grey here, showing the lowest likelihood. And consequently, governments know where to focus their investment in the strongest buildings. Governments know where to educate people the most about how to prepare for earthquakes. And finally, governments know about where to protect their coastal towns against tsunamis the most. And so people don't waste their money building earthquake-resistant buildings here, but rather invest most of their money here, such as Chile, as these are the places at highest risk. So hazard maps are an effective strategy for helping a government prioritize different areas for investment in technologies and defenses, protection against earthquakes. And finally, people need to be informed about what to do should an earthquake strike. This is the Tokyo Earthquake Handbook, and it is given out to people every year in the city of Tokyo, the largest city in the world, the capital city of Japan, which sits on a destructive plate boundary on the Pacific Ring of Fire, the most active plate boundary area in the world. And this guide educates people in exactly what to pack in their homes in case of earthquakes, exactly how to prepare in the event of an earthquake, for example, hiding under tables and holding on. And it teaches people about where they should stay should their house be damaged, and who they should call, and what they should do to protect their house so that earthquakes cause less damage to their homes. And this manual, used in countries around the world, but most effectively in Japan, has been proven to have saved many lives as the people are well educated about how to react after an earthquake. Time to assess learning. Question 1. What is cross-bracing and how does it help? You should have said that cross-bracing is an X-shape design for building structures made of concrete and steel. The X shape helps because it shakes less and it sways less in an earthquake than vertical pillars. Consequently, the building is much less likely to be damaged. An example you could have used was the Transamerica Pyramid in San Francisco on the west coast of USA. Question 2. Why is it important to plan for natural hazards? Planning is vital because it saves lives. It prevents people from being in homes at the time of earthquakes. It ensures that people are with food and water and medical supplies after a natural hazard event. And it also ensures that people are protected against things like tsunamis, secondary hazards, which prevents further loss of life in the hours and days after an earthquake. Question 3. Why is prediction only a suitable approach to monitoring and managing natural hazards for volcanoes rather than for earthquakes? Earthquakes currently cannot be predicted very effectively. Volcanoes can be, and consequently prediction technologies form a vital part of a country's efforts to manage hazard risk. Okay, time to embed learning. I'm going to show you one question. Answer the question using the keywords and the structure I've given you. So make sure you have as many of these keywords as possible, underline them when you use them, and explain your answer like this. First paragraph, and then give an example, and then explain how it helps, and then do that 3 times. For 6 marks, you need to give 3 different points. So for example, 1 for prediction, 1 for protection, 1 for planning. You need a specific example for each, for example, a place, and you need to explain how each helps. If you've done those 3 things, then you've got 6 marks. 4 marks for only 2 points, 2 marks for only 1 point. You get a maximum of 3 marks if you haven't used any examples, or you haven't explained clearly. From the lesson, write 2 questions from memory, and then answer them. In a week's time, test yourselves on those questions until you have memorized them. This will help you ensure that you have learned the ideas from this lesson. Next lesson, we're going to dig deeper into the question of why do people choose to live in risky areas? It's not just about the technologies we have to manage hazard risk. There are other factors in play. Join me then.